Anna as well. Look at that. It's worked. It's worked. How exciting.
Very good.
Just a quick hello to everyone who's joining, and hello to Anna, who we were having a few technical difficulties. We will hang fire just for a few more moments whilst more people join, and there's quite a few people joining, which is great. We'll wait a couple of minutes for a few more people to join, and then we'll kick off. For those who've already joined, we do invite people to ask questions through the Q&A through the course of the discussion. Yeah, don't leave all your questions to the end. It keeps it lively and engaged whilst we're talking. So yeah, feel free to use the Q&A section at any point in time. So we'll wait for probably one more minute before we get started, and go from there. So I think we will make a start. We've got, I'm sure there'll be some more people joining at various points, but good afternoon, and thank you for everyone who's joined in, and welcome to the 8th in the Meaning of Light series of talks, and of course a huge welcome to Anna Levin, Bob Fosbury, and Simon Thorp for joining us today as we talk about designing for darkness. So thank you very much for joining us. Just a little bit about the series. The Meaning of Light series is a series of talks exploring the topic of light and our connection to it. This time, however, we're looking at darkness as opposed to light. Something that Bob and I have spoken about quite a bit over time is that all life on Earth evolved under the full solar spectrum. At the same time, all life on Earth has also evolved with darkness. And so, with that in mind, what about darkness? And we'll explore that during the course of the discussion today. On a personal note, and in general, we've recently been gifted with being able to see the planetary alignment, and I've felt personally quite a connection to the planets whilst walking home from work in the evenings, with Venus, Jupiter, and Mars in particular, because they're the ones I could see on a regular basis. Feeling them sort of as sort of friends in a certain sense, accompanying me on my walk back home in the dark winter evenings, and this in itself changed my perspective somewhat, and I'm finding myself spending more time looking up these days at the night sky than I might have done before. So I think we're going to dive into sort of emotional aspects, probably clearly some scientific aspects, and the design context over the next hour or so. As I said before, as with previous talks, please feel free to post questions into the Q&A section. Don't hold the questions back till the end. Feel free to do so, and I'll interject and ask Anna, Bob, and Simon questions through the talk. So maybe without further ado, Anna, Bob, and Simon, starting with you, Anna, if you wouldn't mind introducing yourselves, and over to you, Anna.
Hi, thank you, and great to be here. Thanks very much for inviting me back again. I'm here to talk about a wee book that I wrote that came out late last year, appropriately called Dark Skies. And it's really about my relationship with a guy called Alan. I don't know if there's any Alans present. I've been scanning through the list of people here, but apologies if there are, and it's nothing personal to you. But I've been hearing an awful lot about this guy called Alan, which is the acronym used for artificial light at night. By people that are concerned about the loss of darkness and the increase in Alan, and partly because of the name, I sort of came to think of this quite swaggering guy who's out on a rampage, really doing an awful lot of damage throughout the world and completely oblivious. And Alan's also something we created, by almost worshipping light, by loving light, wanting light everywhere, having these associations that light is good and darkness is bad. And this guy Alan is sort of beating darkness back as he's striding over the world. And I'd say he's gone wrong. He's out of control, and really it's about trying to renegotiate our relationship with Alan and get a sense of balance back. I was asked to talk a bit about my journey here. I mean, I came into this subject as a wildlife natural history writer mostly, looking at passion for marine environments, and had really never considered thinking about light or darkness, especially in those terms, and especially not as an environmental issue. I started getting concerned about the impact of the changes in artificial light in human health, and people that were struggling with some of the new lighting technologies, and that led me with a complete starting from the beginning with physics to really say, well, what is light? What is the difference in the stuff that's coming out of one light, an incandescent or an LED or a CFL? What do these acronyms mean, and what's it all about? And that that led me on a long journey that I counted in a previous book, Incandescent. But I felt like I was on a very strange planet of politics, physiology, and international legislation, and physics. And I thought I was a world away from writing about dolphins and otters that I'd been doing before. But there was no turning back. And as I got deeper into it, I started going to dark sky conferences and dark sky meetings and reading papers about Alan. There's a whole database of so many papers coming out, and scientific papers looking at the damage that Alan is doing. And that's where I started encountering the marine environment, the seabirds, the turtles, the plants. I'd been working at the botanic gardens, and every aspect of the natural world was being affected by this Alan. So for me, it all came full circle, and really understanding the depth to which this is an environmental issue. And human health isn't a separate thing from that. Of course, it's part of this. We all have nervous systems, we all have eyes, we are living beings, and this whole issue is about how life interacts with light and how we underestimate the impact of light. And whenever we talk about light, we're talking about darkness, and whenever we talk about darkness, we're talking about light, because this is, it's all about the balance between these two, and really getting to understand how light is time in the natural world, of which we are, of course, a part. And by altering the pattern that Ulysse referred to, that's of light and dark, that's been there as life evolved, we've broken that clock, and we've ripped up the calendar, and we've caused havoc with the air traffic control and everything that's coordinated. Time coordinates life systems, and light is that time. So we've really messed up with everything. And I think I'm very engaged in an environmental world that seems still quite oblivious to this issue. It's really only creeping from these Alan conferences and from ecologists and sort of studies into a more wider environmental dialogue. And I think that's one of the reasons I wrote this book as a very introductory, hopefully accessible wee guide to maybe introduce the subject to people that are concerned about and aware of their environment, and aware of wanting to make less impact, that really maybe haven't thought about putting lights around their pond or having lights in their gardens, or just what lighting at night is doing to the natural world. Because it's not it's not a seabird problem or a turtle problem, it's a problem for life on Earth and us. So I came round to, I was writing to coming up with an acronym brother for this Alan guy, and so I came up with DAN, which is darkness at night, and really aware that in the world we live in, we're not talking about getting rid of Alan. I couldn't live without him myself. I like a torch in my pocket if I go for a walk. I try and keep it off. And we need a level of lighting at night, but what we need is to calm him down, calm Alan down, and give space and give respect, and start to really treasure Dan as something. Dan can restore the damage that Alan has done, and getting a better balance between these guys really is the way forward for life on Earth, including us.
Brilliant, thank you, and I love the new acronym Dan. I've not come across that before, so that's brilliant. Bob, if we can move on to you, and if you can introduce yourself to those who don't know you already.
Okay. Well, I come to this subject with two hats. I'm in two different periods in my life. I'm an astrophysicist. I worked on astronomy for 50 years using big telescopes around the world, and in particular using space telescopes. And so I'm very aware of the night sky, both from the ground and from space. And I'm fortunate to have had a very unusual experience of being on tops of dark mountain sites all around the world at night with the moon down, because I was always looking at very faint objects, the edge of the universe kind of stuff. And so I'm very familiar with being in a really dark sky. And I was thinking about what I should say today, but I think I'm going to focus on the emotional and intellectual value of being aware of our surroundings. And many people today are not aware of half the volume surrounding them. They're aware of what's going on the ground, but they're not aware of what's going on in the sky, because mostly they can't see it, and particularly at night they can't see it. And if you look back to the development of human thought and civilization, the people who started this, before we even know, the people who started this were aware of a dark sky at night. They lived it. They lived it every day. They lived through a dark sky. And the role this played in the development of human ingenuity and intellect and curiosity, I think, is extraordinary. Without the sky, I don't think humans would be anything like as curious as they are. So it was really the birth of the attitude that eventually ended up being called science. What's all this stuff going on in the sky? We see all these bright points of light, we see all these changes, we see the moon, the sun. What on earth is going on? And that was the primary driver of science, in my view. I mean, I don't think there's any dispute about that. It was the primary driver of science. And I also remember some experiences when I was in very particular places, in very dark skies. I remember being in the central part of Australia once with my young children, and we stopped the car at midnight after going out to dinner in town, and we were actually at the Parkes Radio Observatory. Many of you will have heard of the dish, the famous dish that appeared in the movie, and also was very much responsible for receiving Apollo transmissions from the moon in the early days. I observed at the Parkes telescope quite a lot while I was in Australia. And I remember opening the door of the car and letting my kids out. And the first thing they did when they got out, it's completely dark, they looked up and the Milky Way was stretched right across the top of the sky, the zenith. We don't see this in the Northern Hemisphere, unfortunately, but if you've seen the dark sky in the Southern Hemisphere in the southern winter, it's so spectacular. It's the galaxy. You can see it's the galaxy and it's over you. And I just remember the mouths of my kids opening. So, what's that? And it was such a dramatic experience. So I think we have to value the ability to see things that are around us. We don't have real spatial awareness unless we can see the sky at night. We can't see the universe. And, I've been struck by this so many times, to be on the top of a mountain in a very dark site when everything is dark and just look around. It's like being in another world. It's not dark at all. It's a billion times fainter than it is in sunlight at daytime, but it's full of information. Right out to the edge of the universe. It's there implicit in the sky, even though with your eye you can't see so far out. The big telescope sitting next to you at the time can, so you can actually see out to the edge of the universe. And it's the ultimate exercise in spatial awareness. It's humiliating. I mean, it's humbling because it's just so enormous and full of information. So for me, that's, I think, the main value of creating the ability for people to see the dark sky. Now, my other hat is studying the interactions of light with biology, and we're doing this in great detail with all kinds of quantum biology and so on. But it's very important for that process as well. As Ulysse said, we've evolved under full spectrum sunlight. For some reason, we've narrowed our concept of light to visible light, which nobody really thought about this before the invention of different kinds of artificial lighting. But artificial lighting is designed to be maximally energy efficient to produce visible light. And it doesn't produce anything else. It just produces visible light. Nothing like the full spectrum sunlight. And that was a big mistake. That was a really big mistake. We didn't realize it at the time, what a mistake it was. But now we're reaping the consequences of this in seeing declining public health, all kinds of problems with, mental and physical health. And we've somehow got to reset all of this. So I think the awareness of darkness at night is a powerful reminder that, our body works in quite different ways. And our body, the whole biosphere, works in quite different ways at nighttime and in daytime. At nighttime, many living creatures, animals, plants, fungi, are all doing housework, and they're repairing their bodily functions and so on, getting themselves set for daylight. And when the sun comes up, your whole process of metabolism changes. It's just like a switch. You don't notice it so much because your body reacts to the change from dark to light. But on the other hand, things are going on in your body in a very, very different way when you're exposed to sunlight. And I think that's probably all I'll say at the moment in my introduction. I have more things to say about other kinds of light pollution, but I think it's really the concept of where we are and what we are, where we live, and our spatial awareness. The dark sky is especially important in this.
Brilliant. Thank you very much, Bob. And Simon, over to you.
Thank you. Hi, everybody. Yes, Simon Thorp. I'm a lighting designer at LAPD Lighting Design. I've been a lighting designer for about 20 years, and I've sort of worked on all the sort of different disciplines of lighting. But I've always had a keen interest, and I've always looked at public realm lighting within that. And I sort of came to the darker side through almost the other way around. What got me into lighting was studying daylight and its influence on architectural spaces, but also its ability to heal. Its influence on humans and the way it can improve the rate of healing in hospitals, and conversely the effect it has when you have a lack of daylight in offices or internal spaces. And I think there was always a consideration of darkness. In Praise of Shadows was another book that made me want to be a lighting designer. And there was always within the projects this respect to an extent of darkness, but it didn't go that far. That there would be uplighting within projects, or but they'd be switched off, or there'd be some element of control. And now I've sort of come the other way around. I've looked a lot at how I've realized how light influences the rest of the planet in terms of the wildlife, and the effect of artificial light at night that it has on every human beings and everything. And it's just sort of case of I wanted to do a bit more, and I wanted to try now within all of my projects to try to get the message across to reduce the impact of artificial lighting at night. And I sort of also strongly believe that the night sky, and Bob mentioned this connection with the night sky, is so important for what effectively it is to fundamentally be human. But I don't think it is something that should be confined just to rural areas or quieter areas of the planet. It should be, the aspiration is to be able to see the night sky within towns and cities, and be able to work with get that balance between humans and nature.
Brilliant. Thank you very much, Simon. So, if I can maybe get things started a little bit, I've been thinking about this for a little while, but it seems that we have this sort of strange relationship with light and dark, and we've known in the concept of light, we've known about photosynthesis for about 250 years, yet we've either ignored or failed to understand that light drives off a whole series of physiological responses in humans, clearly beyond the visual spectrum. So we've had a better grasp of light for nature in that sense. On the other hand, we've now got a pretty good understanding of the impact of light at night on humans through circadian science, and yet we seem to sort of ignore the impact of artificial light at night, or Alan, on the natural world. And so question that has to come out, and I think we sort of know the answer, but I'm not going to answer it right now, is have we inadvertently created a harmful environment, not just for the natural world, but for humans too? And maybe that's a starting point to discuss how important is our dark skies, how important are they? So I don't know. Anna, do you want to think of it, or come back to me on that one as a starting point?
Yeah, I mean, I think you've hit the nail on the head then, that we've inadvertently, whether with good intent or not, done some damage. And with the change in the lighting environment and the a massive increase in light pollution in the last few decades, we've harmed the living world that we're a part of. And I think it ties back to what Bob says as well, that it's not, it affects our physiology, it affects our psychology, and it affects our imaginations and our the more fundamental bits of the way we think. Because I think this Alan isn't starting to think of it as a pollutant, that light at night is a form of pollution, just like air or water pollution, that we need to legislate about. But Alan is also a thief and has stolen this treasure that's really ours. And it's just very important not just to experience darkness, but to be able to experience the rest of the universe and the view of the night sky. That every human culture has engaged with that and questioned it and woven myths and dreams and built science around it. And it's something that we need and something that we have to have. I gave a talk up in the Highlands a couple of weeks ago, and we're opening a dark sky hide, and one lady said, when we saw the night sky every night when we were young, we never really thought much about it. We weren't all sort of wow and wonder. And she said, it was just normal. And I was thinking, that's maybe akin to a tree. If you see trees every day on your, when you're heading out your house, you might not stop and go, wow, unless they're doing something particularly amazing. But if you take them away, and you realize that you've lost, and generations were growing up without ever seeing a tree, you'd come back to them thinking every leaf was a miracle and amazing to watch. And I think that's really it should be normal. It should be part of our normal human experience. And it's the loss of that people are actually growing up without ever having seen a pristine sky. That's really troubling.
I can imagine that there's a generation of young people at the moment who have grown up in inner cities, who have never experienced sight of the night sky in its let's say, I'm certainly not in the middle of a dark sky area, but I'm certainly have the pleasure of seeing the stars at night when it's a clear sky. Like there are children who probably haven't seen certain animals, and farm animals. Maybe there's a whole generation who are missing out on seeing what the night sky, the wonders of the night sky in that sense. So maybe Bob,
why don't you show some pictures? Show my first three pictures.
Shall I show some pictures? Okay, here we go.
If people don't know what a dark sky looks like, you can have a show.
Let's go. Has that
I can see that. Yeah, but make it full. Oh, okay. I can see. I can't see it full screen myself.
Oh, can you not?
No.
That's weird. Let's try. Did it work this morning? Didn't it? Let me escape from that.
Well, just leave it like that. That's fine. Go back.
Is that okay?
Yeah.
Okay. Let's go there then. And let me share my screen once again. Actually, might be easier if I do that. There we go.
Yeah, that'll do. That's fine. So
let me just try and expand it now. There you go. That should work.
Okay. I've chosen 3 images only. There are all 3 extraordinary images, and these are taken in places where there's very little light pollution. In fact, here there's probably more light pollution in this picture. It was taken in Latvia, This was a picture that won a competition in Nature this year. The extraordinary picture of the aurora and the Milky Way rising up from the horizon in a pretty dark sky. And if I look at that as an astrophysicist, if I look at that, I think there are just so many fascinating physical processes going on in that picture. It would be hard to describe. But what I will say is, if you look at the aurora, which is a wonderful thing, it's interesting that this picture shows you how bright the aurora can be. I mean, it can be brighter than the Milky Way, which is fascinating, I think. And the point I would make about the aurora is actually produced by energetic particles coming from the sun. We have a very active sun, and the energetic particles travel through 193 million miles and interact with the Earth's magnetic field near the poles. And those energetic particles excite atoms and molecules in the atmosphere to radiate light. And the dominant colors in the aurora are red and green. You can see some blue, purple in this image, but the dominant colors are red and green. And those are due to oxygen atoms. It's not in the aurora, it's not the oxygen molecules. The molecules are split up into two oxygen atoms, so they're separate oxygen atoms. And it's those oxygen atoms that are excited to radiate green light and red light, and other colors as well, but predominantly green light and red light. And we see those emissions in oxygen all over the universe. I mean, they're very familiar to an astronomer. We know the wavelengths off by heart, and we see them all over the place. But if you move to the next image, Ulysse. Yeah, this is a picture taken from one of our observatories in northern Chile. It's one of the best observatory sites on the planet. And this is a dark sky in Chile. Okay, this is 1 billion times fainter than the irradiance of a fully sunlit day. It's an extraordinary number, 1 billion. And the only reason we can see this is because our eyes have evolved to give us an enormous range in sensitivity, brightness, right from full daylight right down to this very low level. Now, I'm shooting here because this image is actually taken with a color digital camera by a very good friend of mine, Yuri Beletsky. And you see the two colors. You see the red glow and the green glow on the horizon. That's the same oxygen atoms that are producing the red and green in the aurora, although those oxygen atoms are excited in different ways. They're excited by ultraviolet radiation from the sun during the day. It makes them excited, and that excitation lasts for a number of hours, and they get rid of this light during the night by radiating green and red light. And again, I find that intellectually, this is a really powerful message. The fact that we see those glows, I'm not talking about the galaxy and the distant universe, I'm just talking about the Earth's atmosphere. The fact that we see those glows at all is simply because we have photosynthesis on the planet, because it's the photosynthesis that releases all the oxygen into the atmosphere that allows it to be excited. So if you're a biologist looking at a planet and you see this red and green glow, you're pretty sure that there's photosynthesis going on. It's the only way of getting oxygen into the atmosphere. So this is a sign of life. And then we look out and we see the arch of the Milky Way. We see that the fuzzy blob just above the mountain there is the Large Magellanic Cloud. It's our nearest significant size galaxy. And it's a factory for producing chemical elements. It's producing all the periodic table continuously as we watch it, as is happening all over the universe. It's, before these galaxies formed, we only had hydrogen and helium in the universe. And all the heavy chemical elements, all the chemical elements in the periodic table above hydrogen, helium, and a little bit of lithium are made in stellar processes through the history of the universe. And the Large Magellanic Cloud is a very active star-forming galaxy where all these elements are being made at this very moment. So that's, we don't see the red and the green with our eyes because the sensors we have in our eyes at night, the rods, are very, very sensitive. They're much more sensitive than the cones, the three kind of cones that give us our color vision. But of course, we're colorblind at night because we only have one type of rod. So we only see the bright glow. We can see this glow, but we don't see the color. It's too faint to see the color. And just finally, on this series of 3 pictures, as the last one, I think it's a lovely picture because the Milky Way is stretching vertically out of the horizon. You still see your red and green glow on the horizon, but you see this faint sort of grayish bluish glow going up from the right-hand side up to the middle of the picture at the top. This is the debris left over after the formation of the solar system. So it's the dust left over, along with the asteroids and so on, in the plane of the solar system, which is scattering light. It scatters blue light somewhat better than it scatters red light, and so it looks blue, like the blue sky. And this is what we see in the plane of the ecliptic when we hide the sun in a dark sky. So, you know, you have all these different contributors to a dark sky, which many people are not aware of. You have the aurora, you have the air glow, you have the distant stars, you have the galaxies, you have our own Milky Way above you. And if you haven't seen these things with your naked eye, you really should get on a plane and go to the southern hemisphere and find a nice dark place to look. It is absolutely stunning to look at. So that's really, I mean, I think that reinforces my story that, you know, intellectually, the human race has developed largely because of trying to understand what's going on in the sky, to figure this out. And, you know, now we've reached a state where we can actually comprehend and understand the evolution of the universe as we see it, right from its early stages to now. And where did that intelligence come from? It came from the development of complexity during 4 billion years of biological evolution. Layer upon layer of complexity was added by Darwin's, survival of the fittest process, the selection process during 4 billion years of history. And it's got us to the stage where we can think these complex thoughts and build a model of how the universe is working. And isn't that an extraordinary process? It's the raw material for this evolutionary process is time. It's 4 billion years of trial and error and evolutionary process. And we're now coming to a very critical part in our history because we're at the stage where we're beginning to hand over this product of the evolutionary process in a digested form to computers as the AI that they're learning from. The construction of these large language models and so on, which contain all the information that we have derived from our brains through a process of biological evolution. And when we hand this over to AI, if it happens, we will change the raw material that the evolution process uses. We use the raw material of time, 4 billion years. It was a very, very slow process. As soon as we hand this over to computers, we will evolve billions of times faster than we've evolved up until now. And that's really scary.
Before I hand over to Simon, I have a question for you, Bob. You mentioned that the colors, the oxygen that is in the sky, the colors coming from the oxygen, is the process of photosynthesis. Is there if we overlight our natural world, is there an impact on the release of oxygen in any way, or just a question? It might be a silly question, I don't know.
No, it's
does
not.
that then impact the oxygen molecules that are then giving us color?
Well, yes. I mean, if you don't photosynthesize, you don't get oxygen in the atmosphere. I mean, the oxygen would decay. It would oxidize the rest of the planet if we didn't have a continuous input of oxygen from photosynthesis. So, there are non-biogenic ways of making oxygen, so there will always be a little bit of oxygen in the atmosphere, but there won't be anything like as much as what we have at the moment. And oxygen is rare in atmospheres, I'm sure, when we look at exoplanets and so on, and it will be most probably an indicator of life, not certainly, but it would most probably be an indicator of life. But the thing is, the plants have adapted to use the light that they're getting from the sun, and it's very finely tuned, a very productive process. I think what we're learning at the moment is that there's a parallel process going on to photosynthesis, which has not yet really got an established name, but I'm hereby naming it photometabolism. This is a process which, in a similar way, uses invisible light to take the products of photosynthesis, the food that's been generated by all the plants that we eat and animals eat, and we eat the animals, so indirectly we're eating photosynthesis. The animals are parasites on plants, basically. They take the products of photosynthesis, the sugars and carbohydrates that are produced by plants, and we parasitize that, and we eat either directly the plants, or we eat the animals that are fed on the plants. And it turns out that in order to metabolize the foods that come from photosynthesis, the energy processing systems in our body need the near infrared light, the light beyond the red end of the spectrum, the non-visible light beyond the red end of the spectrum. We need that light to drive the process of metabolism efficiently. We can metabolize in the dark, but if we do it for long, we'll get sick. We know all the astronauts in the space station who stay for 6 months in a tin can without ever seeing the sun come back sick. I'm sure submariners come back sick from being months under the sea in a nuclear submarine. So we need exposure, not continuous exposure necessarily. We need occasional exposure to sunlight to make our metabolism work. And also to make our metabolism work, we need the darkness, because we need periods when the body is doing different things. And I'll give you one example. We don't actually know, we've not had a chance to prove that this is true, but you'll all be familiar with the fact that reptiles come and bask on rocks on a sunny morning. And any biologist will tell you they come out because they're cold-blooded and they have to warm up in order to become active. Well, we think it goes much deeper than that. The reptiles come out because they have to energize their mitochondria, the energy sources, the little engines and batteries in their bodies, which give them energy. So they need to switch on their metabolic processes by basking in the sun, and when they get out in the morning, and that gives them plenty of energy to run around and catch insects or run away from predators that were going to eat them. So, it's during the night that these energy processing mechanisms in our body are rebuilt and refurbished and serviced and so on. So we need the darkness at night, and we need the sunlight during the day. We don't need it all the time, but we need it. We need it, and if we're starved of this infrared light during the day, our metabolic processes will decay and will suffer all the diseases of aging, type 2 diabetes, obesity, Alzheimer's disease, cancers, and so on. All of those are much more prominent when our mitochondria are not working properly, when we don't metabolize properly. So it's really, really essential that we have exposure to both the darkness and the full spectrum of sunlight. And even the dermatologists will tell you these days that you should get out in the sun. You shouldn't bask in the sun for 2 weeks in August and then put clothes on and never see it again for another year. That's not the way to do it. But you should be regularly out in sunlight and daylight. Shadows is fine. Sitting under the shadow of a tree is probably the most healthy place you can sit. And so I'll stop my discussion there. And you can move on.
It's actually, as you're talking, Bob, I just dug something out. When I try to get to schools or landscape architects and sort of talk to them about light at night and you know, the detrimental effects of it, how it affects humans. I've got a slide here that's just sort of maybe illustrates an aspect of what you're saying. If everyone can see that.
Yep.
If you start bottom left, you know, this is the spectral distribution of sunlight, and you know, during the daytime there's a lot more blue and it's a lot more even, but this is the sort of light that we evolved over, you know, an extremely long time experiencing, you know, when night came. And then top left, we then used fire, which has a strikingly similar spectral distribution to sunset. And then we had incandescent for, again, a very long time, which also sort of is similar to both those curves. And then all of a sudden we've got this bottom right LED distribution. This is a 4000K sort of typical LED curve, with the big spike of blue, but with all of that red missing as well. And that's what we're sort of exposing ourselves to at night now, and also the rest of the planet. So it's unsurprising that if we're sort of designed and have been designed to be subjected to those sort of the fire and the sunset and you know, even incandescent worked because it's a more natural light source, but the LED is creating these issues that you're talking about.
Yeah, I couldn't. I mean, I couldn't have said it better. I think that is the point. I think that the point about the strong blue, though, I think there's been a lot of confusion about this. We all hear about blue light, the dangers of blue light and blue light blocking glasses and so on. The blue, you showed that spectrum of sunset, which obviously was pointing towards the sun. In fact, sunset, once the sun has dropped below the horizon, is incredibly blue. And in fact, Ulysse, I think I've got a chart of that on my set of slides, two after the last ones that we showed. And I think this is important to point out because, you know, for the circadian people to realize that natural light at twilight, when the sun is just below the horizon, and for, you know, for a while after sunset and sunrise at our latitudes, it's about half an hour or an hour. It's called the blue hour by the French artist. You know, it's a special time of day and night when the light is extraordinarily blue. And it's a misconception to think that sunset is very rich in red light. It's much richer in blue light than it is if you look behind you. When you're looking at the sunset, look behind you and it's incredibly blue.
I think maybe Bob, yeah, because you've been doing some work with Scott recently, Scott Zimmerman, you know, and Scott's had his cortisol sensor. You know, I think you know, is it appropriate to sort of talk about, you know, maybe what's happening, you know, in a physiological sense when we are exposed to Alan, you know, because it's not just in indoor environments, it's you know, externally, and actually, as I speak, Scott is just joining the call. So you know, Scott's just a participant here, but welcome to Scott, and we've just been talking about you, Scott. So there we go. But yeah, so you know, you know, Scott's been, you know, wearing this sort of cortisol sensor and observing, you know, cortisol spikes just through light. But maybe Bob, you've got a little bit more information on that.
Yeah, I think it's a very interesting point, and Scott and I have discussed this many times. That I think that I mentioned that the dynamic range of light, we call it, the range between full brightness sunlight and the darkest dark sky, is a factor of 1 billion. That's a big factor, okay? And it turns out that our sensitivity to light seems to be a sensitivity in ratios rather than absolute values. So if you go down into a dimly lit sky at twilight, you know, it's maybe 1,000 or even 10,000 times fainter than full sunlight, you're still very sensitive to the ratios between blue and red light. And the problem with the LED is that it has very strong blue and it has no near infrared at all. It's dark in the infrared. So if you take the ratio of near infrared to blue or the other way up, it's either 0 or infinity with a white LED. Whereas all the other light sources we've been used to have a ratio which is almost 1-to-1. You know, it varies a bit with daytime, you know, full daylight and blue sky and so on. It varies a little bit, but the ratio of blue to deep red light in thermal sources like the sun is around 1-to-1, roughly, you know, very roughly, a few to a few, but it's very different from infinity or 0. And that's the origin of the problems we have with the blue light. It's not the fact that we got blue light, it's the fact that we have blue light without any red light, and our body just cannot cope with that. So, you know, at twilight, you think of the sun, you've been looking at the sun, it's a deep red color and it's lovely and it contains lots and lots of red light. At twilight, the sky is predominantly blue, but that blue is not nearly as damaging as the blue you get from an LED, because along with the blue, you have the red and the infrared. So that's the problem. That's the problem with the artificial lighting. It's the fact that it's restricted to this very narrow range of just the spectrum, the visible part of the spectrum, and it's driven by this blue spike. It's the blue spike that's creating the light. The green colors and the yellow colors and the red colors are produced by phosphors that are glowing in the lamp, illuminated by this very strong blue source. And these phosphors, it's very hard to make these phosphors to go far enough into the red to create infrared light. And it turns out to be much easier to make infrared light just by making something hot, like a light bulb, an old-fashioned light bulb. But it's the fact that we're dealing with this huge range in brightness. And if you wear blue blocking glasses in the daytime and you say knock out 30-40% of the blue light, you've still got huge amounts of blue light there. It's not really making any difference. And, you know, it's changing the ratio a little bit, you know, but the ratio is changing anyway. So, you know, blue blocking glasses is, frankly, a waste of time.
So yeah, maybe it's time to shift to talk to Dan, or talk about Dan, maybe rather than talking about Alan. So maybe with the start of talking about Dan, you know, and you know, maybe start with Simon on you know, maybe solutions and innovations, and then yeah, we'll talk through how do we get Dan back.
Oh well, I think. I mean, the spectral distribution obviously is really important, but at the end of the day, if we don't need to light, then maybe we don't light, which is I think happening a little bit more. Questioning, lighting designers and planners are certainly questioning, do we need to light in the first place? But there are solutions, and LED, although it's been a problem, particularly over the last sort of decade, it can have its solutions, and you know, one is the fact that it is dimmable. Older technologies, metal halide and SON and SOX, they weren't dimmable, so they had to be on or off. So we can, you know, potentially reduce light levels to a low level. We can tailor the spectrum. You know, there's PC amber, which has no blue content, limit the amount of you know, visible spectrum, you know, into the darkness. There are also technologies where we can try to strike that balance with nature and humans, where it can be, you know, on at a very low level with a very warm light to indicate that there is a route through a sort of a park at night, for example. But then on presence, it can just ramp up slightly, and it can cool down just to increase, you know, the color rendition. You know, that type of thing is now the technologies within the driver, within the light fitting, and not necessarily part of a complex control system. There are also systems that work as well as on a you know, on a daily basis. There's a sort of seasonal programming within them, and there's, you know, there's even some applications of red light. I think for me also, one of the biggest things is glare. Within the nighttime scene, glare is massively important, and 5 lux in one scenario isn't the same as 5 lux in another scenario. If you've got no glare whatsoever, completely comfortably lit environment, you can get down to really low light levels. If you've got glary light sources everywhere, you almost need to keep adding. People keep adding glary light sources because they feel like they need more light. It makes other spaces appear darker. So glare to me is probably one of the biggest sort of aspects of design that sort of could be improved.
Anna, some thoughts?
So repeat the question again, because I'm thinking about glary headlights.
We're not necessarily a question, but just talking about bringing Dan back, and Simon was obviously talking about glare being an issue. So I know that you're not a big fan of glare, that's for sure.
I'm not a big fan of glare, and I'm very aware and very actively campaigning at the moment with a charity Light-Aware about the problems of car headlights, because of course we've got mobile light pollution with car headlights that have got incredibly bright, and it feels like an arms race of things getting brighter and brighter and everything needing to be brighter. And it's also a discriminatory issue, because a lot of older people aren't able to drive at night anymore because it's harder for their eyes to adjust to that dazzle and then coming back. So I think it's a safety issue, it's a discrimination issue, and all these things are interconnected. But I think in terms of giving space for Dan, and I think it's what we can all do just to question, as Simon said, and not just presume we need light everywhere, but really think about what light do we need and how much do we need, and what's the minimum that could do the job, and what's the best way to do the job. And the other thing that we need to do is complain, because an awful lot of people are really unhappy with their streetlights being far too bright, and people are putting blackout blinds and taping bits and sort of stuffing towels on the top of the curtains and we shouldn't have to sort of black ourselves in to have darkness at night if the streetlights are too bright for people to sleep. But again, with the charity Light-Aware, they sent a freedom of information request to councils throughout the UK, and asking what street lights they'd installed, and whether there'd been any inquiries into environmental impacts or health and safety, and also what complaints they've got. And one of the things that surprised me was how few complaints there were compared to people actually quite unhappy with the street lights for various reasons. People found them cold and ugly, and often far too bright if they were close to the houses. So I think just being more conscious of light and being more emboldened to complain if it's not right. If there was a sound that was intrusive, you'd be quite quick to be onto the council about it. And I think we need to think of light in the same way as something that's really disturbing.
And Bob, I know earlier we were talking about sort of let's say the horizontal aspect of light. Where it appears, high up, low down, all those sort of things. So maybe some thoughts on positioning.
Yeah, I think actually I remember giving a lecture at one of the Daylight Academy meetings where I gave it in the evening, and they set up for me an LED campfire in the lecture room. So we had one light on the ground, which was a slightly flickering red and white yellow light on the ground, just like sitting around a campfire. So we had the talk in the light environment of a campfire. And there is research now going on by anthropologists and so on about the effect of campfires for hunter-gatherers who have this habit of having they have individual fires in the huts to do their own cooking and so on. But in the evenings, these hunter-gatherers tend to come out into a common space and have a common fire, which they're all responsible for keeping going. And that's where they discuss and discuss the town affairs and so on. And we realized that this is a very beneficial light environment for them, because it's not interfering with their circadian process, because the light is quite yellow, amber, and red. It's low down, so it's shining on the upper part of the retina. It's the blue light shining on the lower part of the retina from above, which is so damaging for circadian adaptation and so on. So these campfires play an enormously valuable social role in life for these peoples. And again, we have got rid of all of this, because I know people still sit around fires when they can, but not very many people sit around fires anymore. And in fact, if you think of the people who migrated from Africa out to higher latitudes and up to the Arctic Circle and so on, I mean, the reason these people can survive in these far northerly regions is because they have fires. They have wood fires. They have, if they're Eskimos, they have blubber fires. This is an input to their metabolic process, which is absolutely essential, I'm sure. So there is an importance, as Simon says. The color and the brightness of the light is very important, but where it's situated, I think in general, if you have low down lighting, which is red in color at night, and I try and keep our house lit that way at night. If you don't have the bright white LEDs above your head, you'll sleep much better and you'll feel much more. You'll be much healthier. It's a question of location as well as brightness and spectral distribution, I think.
It's a good way to conceal the lighting too. You conceal the lighting, you take away the glare.
Yeah. Take away the glare.
It's lovely.
Exactly.
Yeah, it's really nice.
Diffuse it. I'm all in favour of diffusion.
So Simon, can we design schemes with light positioned lower down and still sort of comply with sort of legislation? Let's say, is that possible? If I think about two big schemes in London, you've got More London and you've got Granary Square, and it seems that we like to use, for want of a better term, light totems almost. We have big sort of light source reflecting on a reflector above, pushing light back down at quite a steep angle into the eye, clearly sort of having a stimulating effect rather than a sort of calming effect. But can we design at lower levels?
There is always an issue with compliance with standards. It does complicate things. I mean, what always is the case is often you don't necessarily need to floodlight an entire area. You need to ensure there is a lit pathway through an area, and then that allows you to have lower light levels elsewhere. So I think totems and high mast, it does have its place, particularly if you can use a sort of really deep set LED deep inside the luminaire, then you do take it way beyond the eye, the vision, the field of view, and you allow a more comfortable environment. So sometimes it's a mixture of both, but I think the key thing is just being aware that the whole area does not necessarily need to be lit. You can just light ways through.
But of course, Simon, your light from the high pole, of course, is shining onto the ground. So actually, you're seeing the reflection from the ground more than you're seeing the light from the high pole, presumably. Sometimes, anyway.
Yeah. I mean, there are issues when it rains. There's the glare goes up. You have a lot of reflections from light sources in that situation. Yeah.
And Anna, I just wanted to come back to your terminology of the arms race within automotive, because I know that's something that Bob's been aware of for a while as well. But it seems that as we've moved to laser lights, I think they're referred to. the power of automotive lighting has significantly increased, and I do quite like your terminology around arms race. But so is that something that Light Aware is also campaigning against? Oh, you're on mute at the moment.
Sorry. Yes, very much so. And I think it's something that's, ironically got so bad that in some ways it's done our cause some good, because it gives a handle that you can always talk about glare and everyone knows what it is now. And a lot of people that are more light sensitive than others have been struggling with glare for a long time. But I think with car headlights getting so bright and so glary, it's now something that Light Aware has certainly been taking to the House of Lords and working with the Royal College of Optometrists and the RAC, and lots of bodies are actually campaigning on this and saying this really is a safety issue that needs to be addressed. And it's bikes as well. I mean, when I think of an arms race, it's like people think the cycle lights need to be really bright because the car headlights are so bright, but I find it incredibly hard to walk past those really strobing, flickering, juddering bike lights, because they're right at that angle. And all of it's just brighter than we need to do the task of seeing the road or what's ahead of us.
And Bob, because we were talking about eyes before, the aging eye struggled more with that brightness than the younger eye. Is that correct?
Well, I think that the problem with the glare is that the source of light is physically very small. I mean, if you take these laser headlights, the actual source of light is a tiny spot in an LED, which is driven by a laser. And if this is imaged by the optics of the headlight and not diffused or not scattered in some way, if that's imaged onto the retina, you have all this energy going onto a tiny part of the retina. So, you can physically damage you can actually irradiate and fry part of your retina with these point sources. So you've got to be very careful about how these very bright headlights are imaged. And if there's any way of focusing them on the retina, that's incredibly dangerous, because it won't just degrade your vision for a while. It'll fry your photoreceptors, the breakfast in the morning, So
yeah, no, go.
No, I think I think the glare is a very important issue, and it's interesting. I'm just thinking about this in real time, but we're talking about light getting into the body for photometabolism. And of course, the light that gets into the body is very diffuse because it scatters off the cells in your body many, many times. So it's like looking through a bathroom screen or something. It's well scattered. It's not imaged anywhere. It's just photons coming in and getting into your body. So the optics of the light, as well as just the quantity and color of the light, is very important, I think, in all of these lighting systems. As I'm sure Simon will be very well aware of, how you can diffuse light sources to put the light in the right place at the right level of brightness and so on. But we have to be very aware of this. And the other thing that we have come across in the past is when people use lasers for therapies, for using for shining onto bodies as therapies. And of course, you use lasers in surgery for various reasons, and those are often very legitimate reasons. But using lasers for just red light therapy, for instance, I think is potentially very dangerous, because you think that the level of the laser light can be very, very low in terms of total power, but because it has this property of lasers of being coherent, I mean, all the wave trains emitted by the laser are in step with one another. When they diffract off surfaces and irregularities in the body, they don't just scatter light in a uniform glow. They project a caustic. We call it a caustic over a large area. I'm sure some of you have experienced walking under a river bridge with the sun shining off the water and projecting these caustics, these funny hexagonal polygons onto the underside of the onto the underside of the bridge, and as the waves ripple, so these lovely patterns move around. They're very beautiful to watch. If you shine a laser into the body, you generate these caustics, and if those caustics are static, the brightness in particular points in this pattern can be very, very, very high. You're not averaging the light over the body, you're actually focusing spots of light on very particular parts. And this can be dangerous and can be damaging. Even though the laser is very weak, it can be damaging. So we have to be very careful, I think, about the way we use any coherent light sources in lighting. I know, Simon, you won't make coherent light sources for lighting rooms, but we do use lasers for medical purposes, and I think we have to be very careful about caustic generation like that.
And so potentially these sort of automotive lights are taking us in that direction.
Well,
potentially.
I'm not sure. I mean, although they're laser driven, it's not a direct laser illumination that you're seeing. I mean, they're called laser lights because it's actually driving the emission from the LED. But what they are actually doing is exciting the LED, and that I think is an incoherent process. So I don't think that's a particular problem in that case. But nonetheless, I mean, the brightness of the spot on the LED that's emitting all the light is very, very small. And if you've got to be very careful not to focus that on anything.
If I can come back to Dan and Simon, you've run a few or a couple. I think is it 2 or 3 Dark Night events in Hartford?
That's right. Yes, 2 now. Yeah,
2. Okay, and presumably open to the public.
Open to the public. Yeah.
And how has the response been? How's the feeling been from public? And I know you screened The City Dark this year, which is a wonderful film. Yeah, I'm just interested to know how the general public feel about this issue.
The response was good. I think there's a lot of work going in from the top, the sort of legislation side, and I thought I'd try from the bottom up, get the people interested and the people involved. So I suggested to the council in my hometown that we do a sort of switch off, so the community could come together and sort of look up at the night sky, and without nearby glare and a tiny reduction in sort of local light pollution. And the council were really receptive, and we thought we'd open it up for, rather than shut down the town, it's sort of within the park grounds to start with, because we want to sort of build up small, and it was for 350 people, and I thought I'd be sort of drumming up some interest and trying to sort of publicize it, but the first year that it was done was a sort of free ticket event, and the tickets went within sort of 6 hours. So that was a big surprise. We got a clear night on the first year, but we had torrential rain all day up until about sort of 7 o'clock, 6 or 7. And then the second year we wanted to make it effectively bigger each time, so we included the local cinema that had just been completed. And again, the tickets sold out. So we had some tickets available, 80 for the cinema, and 300 for the main event. And you could attend the event if you attend the cinema, and it all sold out again. And the cinema was obviously it's a great film if no one's seen it. The City Dark, really interesting. What we did was do the cinema showing, and then I did a talk afterwards, which I had a feeling maybe everyone will just leave, or half the people will go, but everybody stayed. There's a lot of interest in the topic, and that film in particular it's not new. 2011, I think. It was missing. It was just almost as LEDs were hitting, so there wasn't really any talk of LEDs. So I did a talk then that just sort of filled in impacts of why LEDs, have made things worse, and how LEDs can sort of help a little bit potentially to make things better. But it's been great, really, really good. Yeah, well received.
So potentially, if there's more opportunity to push the DAN topic harder, then it would seem that from the response you've had, there's an open-minded sort of a general open-mindedness to the subject area.
Definitely, yeah.
And Anna, are you seeing the same thing?
Yeah, absolutely. I mean, astrotourism has been identified as sort of the main trend for tourism this year, which is people traveling not just to see celestial events like the Northern Lights and special happenings, but actually going to dark sky places. So I think there's two things happening at once, and one is this exponential rise in Allen and light pollution that's getting worse and worse, but there is also a countercurrent of a huge growing interest that more and more dark sky designated places, more people going to them, more people like the excitement that there's been about the alignment of the planets and celestial houses. People are just craving that in some way, it seems. And I think it's a bit like wild swimming and forest bathing. I think it all comes together with I want to reconnect with the environment that we've evolved to be in, and a kind of craving for that. So I do have hope, despite the fact that things are still getting worse at a fast rate, that there is a real interest in it, and that's growing too.
And Bob, you wanted to
so we haven't actually mentioned light pollution from satellites, and this is very important, of course, for the dark sky people. And I think this is a rapidly growing problem, and fortunately we have some telescopes in space now, so we're immune from that particular problem. But on the ground, where the organization I worked in for many years is now building a giant telescope in northern Chile, an optical telescope, which is 39 meters in aperture. This is as big as a football pitch in aperture. Contains about 1,000 hexagonal segments of very precisely ground mirrors, and it's going to be it's a billion euro project. It's a very large scale project, and that and many other ground-based telescopes, all other ground-based telescopes, are going to be influenced by all these the Starlink satellites, particularly, of which there are a growing number. And although they're only visible while they can see the sun and you at the same time, because they reflect sunlight, so in midnight, generally you won't see these things, but they can create havoc for astronomical observations. Ulysse, can you show my last 3 slides, I think, on that?
Yes, I can do.
That? Just to give an idea of what we're talking about.
Let me get to there, and
skip the next one, and go on to skip that for the moment.
Yep.
So that's a picture of the sky taken over a period of time. I don't know how long the picture was, but it's taken of a clear dark sky at close to twilight, i.e. shortly after sunset or before sunrise. I don't know which. Now you can see all those linear streaks, the straight lines. These are all satellites. Now the irregular flashes in the sky are a meteor shower. So those are actually astronomical events. But everything else is satellites, low Earth orbiting satellites. And if you're doing a survey, if you can move to the next slide as well, please. This is a picture of the night sky taken through these satellite trails. All night sky photographic exposures or photodetector exposures tend to be, tens, hundreds, or even thousands of seconds. And during that time, you can get many satellite trails over the image. So these are a real problem, and they're not only a problem for visible light like this, for optical telescopes. If you're operating a big wide-angle radio telescope, we're developing this new telescope now called the Square Kilometre Array, which is a very large project, which will have antennas all over the planet. or at least focused in Australia and South Africa in particular. Again, a multi hundreds of $million projects, which, of course, these satellites communicate with the ground by high frequency radio transmissions, and they're not very well isolated in frequency, so they scatter huge amounts of radio pollution onto the ground, which is a disaster for radio telescopes. So there are many things going on at the moment which are, apparently uncontrolled. There's no regulation stopping people doing this, and it's destroying ground-based astronomy in many ways. Not completely, but it's a very large factor. And particular, the last picture I have is the development of a new telescope called the Rubin telescope. This is a telescope. It used to be called the Large Synoptic Sky Survey Telescope. It's a very large imaging telescope which images the sky, the whole sky every three nights. So it takes gazillions of very wide field pictures looking for variable objects of various kinds. And this again is a very, very major project. And you can imagine if you're looking for variable objects, and you've got millions of satellites traveling over the field of view all the time, it becomes harder and harder to actually see the astronomical variations and so on. So it's a real problem for projects like this to deal with. So it's a real worry. And this is a very different kind of light pollution, I understand, from what we've been talking about, but it is very, very important.
And actually, the image doesn't necessarily give the scale until you sorry, let me just go back to it, until you spot the car on the road and you realise how big the telescope is. But so I'm going to say something which is really quite terrible in a certain sense. I still sort of get excited about seeing a satellite travelling across the sky, but maybe I shouldn't.
I won't answer that rhetorical question.
So I don't know if anyone's got any questions in the audience who might want to fire some questions to either Bob, Simon, or Anna. But please do so if you'd like to. But for sure, I think trying to get back to a situation where we do have a little bit more Dan and a little bit more less Alan is clearly something that we want to do. And I think, Anna, in your book, and I don't know if you want to touch upon it sort of a little bit now, you do talk about the impact on the natural world, plants and wildlife and sort of plants plants are impacted quite heavily, aren't they?
Yes, and talking of the natural world, just to pick up from Bob's points on the satellites, it's like, we're not the only astronomers in the living world, and we know that, birds and all sorts of other creatures respond to the stars and use the stars for navigation. They don't even know is to talk about how much whales using the night sky for the navigation and for orientation. And when you've got things moving across it, the research really hasn't been done yet to know what impact that sort of celestial clutter and litter will have, on not just astronomers' work, but our own perception of the heavens and how animals use the night sky. So that's also a much wider issue than us. And I think one of the most important things to think about when we're thinking beyond humans is that light itself is a human construct. What we call light is that little sliver of the electromagnetic spectrum that's visible to humans, but that's not the same as what the interrelationship between plants and insects is often about UV light and things can go broad, and what other creatures can perceive is not the same as us. So when you're talking about legislation and you're talking about trying to regulate what kind of light you have, it gets really complicated. We hear a lot about bat-friendly lighting, but different species of bats respond differently to different color temperatures of light, and it's all the complexity of nature's responses to light really needs to be taken into account. And I think you can only go so far with trying to create things for certain species, because actually what all of life on Earth has evolved to is that rhythm of dawn, day, dusk, night, and that's what we need to be getting closest to.
Thoughts on that side, Simon, as a designer in practice?
Well, I completely agree. You know, we almost just need to put things back how the way they were, you know, but at the same time, cities and towns, there's a desire to stimulate the nighttime economy. You know, lighting will encourage people to be out at night and um, to work and to have fun. So it's just that balance. It's how do we create that balance is the difficult part. Reducing light, don't light where we don't need to light. Only light the ways we need to sort of to meet legislation. And even the legislation is being questioned and should be questioned. At the moment, you know, where have the light levels come from? Why do we need to meet certain light levels? They don't always sort of consistent.
Bob, some final thoughts from you?
Final thoughts. I think I think we have to be aware of our history much more than we are. We need to be aware of evolutionary history, and we need to, you know, we're not trying to change the world. We're trying to revert to a world which was more sensible, and I think we'd like to do that in many ways at the moment. But you know, we're not necessarily trying to invent anything new. We're trying to reestablish an environment which was suitable for us and had become suitable for us over a very long period of time. And the speed with which we've removed that environment is quite stunning. And you know, it's happened so quickly, and the way we react to it is not instantaneously. The trouble is the way we react to it is over quite a long period. And this is why, you know, for the photometabolism that we've mentioned a couple of times, we call, you know, the starvation of infrared light, we call this 21st century scurvy. It's very similar to the scurvy due to vitamin C starvation. It takes effect, you know, it took the sailors, you know, a few months to reach Cape Horn when they all had their teeth all fell out and their gums went black and they suffered scurvy. We have the same situation now on the space station. The astronauts go up for 6 months or so, and they come back with pre-diabetic symptoms and all kinds of mitochondrial dysfunction problems because ironically, we send them into space and then we don't show them the sun because it's too dangerous to show them the sun in the space station. But it's absolutely ironic that they come back from sun starvation. And you know, we need to be more aware of how we've adapted and how we've evolved. And so, you know, the sort of recommendations we make about lighting are very, very much based on the sunlight as a standard. So we know that having certain levels of illumination for certain periods of time of sunlight is non-damaging. And so we can sort of work within that envelope when we're proposing artificial light sources, for instance. We know that if we go way above sunlight at any particular wavelength, we've got to be careful and we should be stopped from doing it. But if we're within this envelope of the light that we're familiar with, then all we're doing is we're re-establishing the status quo. We're not inventing a new world. We're re-establishing a status quo. And we can do that. But we need the incentive to do it. And I think the incentive in the long run is going to come from healthcare costs, because, you know, the problems that National Health Service is suffering at the moment. If you look at the fraction of the money that goes into diseases of aging, like type 2 diabetes and obesity, it's huge, absolutely huge. And, you know, frankly, these are the products of what we've done to the lighting, not solely, but in fact, it turns out that the effect of ultra-processed foods on your metabolism are not dissimilar at the quantum mechanical level are not dissimilar from the problems we get from poor lighting. And it's probably too difficult to go into detail here, and I won't attempt to do it. But actually, if you take a real ultra-processed food, that is a food that's made from pure chemicals, the same chemicals that you would get in normal food, but just reduced to individual molecules of these chemicals, if you construct a food from those molecules, you've wiped out all the order and organization that you would have if you, say, ate an apple or ate a piece of meat, which were highly structured food, where you have cells which have to be broken down before you access the nutrients and so on. And so an ultra-processed food is effectively of zero nutritional value. Because all this order that you're using to build your body by eating food, you're maintaining your body functions by eating food. The metabolic process you're doing, the nutritional process, is to import order into your body to keep your ordered functions proceeding. If you remove all the order from the food, that food is effectively useless. It'll make you obese and it'll give you type 2 diabetes, but it won't provide any significant nutrition to you. So we have to be very, very careful of these very processed things. You can process food, you can cook it and so on, no problem. You still maintain a lot of order. But if you go back to my favorite book, which I've shown to you before, by Erwin Schrödinger, this is a book written in 1944 by one of the originators of quantum physics. There's so much wisdom in this book you wouldn't believe. But he makes the point that we eat food not directly to make energy. We eat food to maintain the order in our bodies, to keep us alive. If we didn't ingest ordered foods, ordered nutritions, high energy, potentially high energy materials, nutrients, foods, if we just introduced completely disordered foods into our body, we wouldn't help maintain the order. And in order to establish what we call homeostasis, a steady state of your body, a living body, you would decay into a thermodynamic equilibrium with your surroundings. In other words, you'd be dead. So we eat food to make order, to maintain the order in our bodies, to maintain all these processes which keep our body temperature constant and keep our metabolism working. We're not eating food to make energy directly. The energy is a byproduct of eating the order. So we need highly ordered foods. And it turns out that photons of sunlight are the best possible nutrient, the highest quality nutrient we can have. And they play a role, they play a direct role in nutrition. And the natural substances, the fruits and the meats and so on that we eat that come from natural processes are highly structured and highly ordered, and that enables our digestive process to work much more effectively. And it's just it's proper nutrition. The rest is
and then we subject ourselves to 4,000 K outdoor street lights with no order.
And the effect, the effects of both these things together, these things together, ultra processed foods and poor lighting, are a perfect storm for metabolic health. Perfect storm. The two together, they're not separate. They actually come together. They have very, very similar effects on the body. They have to be seen as a whole.
Anna, you were going to say?
Oh, I was just thinking that the phrase "junk lighting" was coming to me when you
talking about junk
food. Is that
ultra processed lighting? Yes.
Yeah. Simon, some last thoughts on outdoor lighting or ultra processed light or whichever?
I was just thinking of the curry I cooked the other night, which took me. I cooked it for 2 hours because I had to go out and take the kids to places, and it tasted amazing. But was the order broken down too much?
No, I don't think so. Cooking. No, cooking's not a problem. It's reducing the food to its constituent chemicals.
Yeah.
You get the food out of a tub coming from a chemical factory rather than from a farm.
Yeah, with the lighting, it is there is promise, and there is an interest in you know, dark skies and healthy lighting, or lighting for well-being. So there's a sort of a positive message within the lighting industry, I think, at the moment.
So yeah, as we sort of come towards a close, there haven't been any questions as yet. So I'll assume that we're probably not going to see some. But I think it's clear that we should be designing for Dan and trying to bring Dan back, and getting rid of Alan, and saying goodbye to him. So yeah, I hadn't come across Dan before. Very, very nice to meet Dan. Absolutely. So I will come to a close, and I'd like to thank Anna, Bob, and Simon for joining us today for a fascinating conversation about designing for darkness, and for the introduction to Dan. Just a quick reminder, so we've got another talk next month, 1st of May, and we'll be talking to Dr. Geoffrey Guy and Alistair Nunn of the Guy Foundation, and we'll be looking at the health hazards of space travel. So we talked a little bit about space today, but the health hazards of space travel, and questioning how different life back here on Earth is from life on the International Space Station, when we're considering the amount of time we spend indoors today, and what is the impact. And for anyone who's seen the photographs of the two astronauts who came back after 9 months on the space station, they weren't looking so healthy, and maybe that's just an accelerated environment. But yeah, if you can join us in May, please do. I think it'll be fascinating. Again, another talk about how light affects us, in every sense, physiologically, mentally, and so on and so forth. Once again, Anna, Bob, and Simon, thank you very much for joining us today. Absolutely fascinating. Thank you.
Thank you.
Thanks, everyone. Okay,
Yeah.
take care.
Take care.
Thank you.